Logic is the science of correct reasoning. So take note of this. Logic is the science of correct reasoning, because in our geometry for the third quarter, we will start with logic first, because getting inductive and deductive reasoning, this is a topic which is a topic in logic. Okay? And what is reasoning? Reasoning is simply making inferences or drawing inferences or making conclusions from known or assumed facts. When solving a problem, one must understand the question, gather all pertinent facts, analyze the problem. Like for example, compare with previous problems. That's how you analyze. Note similarities, your differences. Then after which, perhaps use pictures or formulas to solve the problem. So this is an example of reasoning. Katong atong gibuhat before, like the thing that we are solving equations, that was already reasoning. Next, let's start with deductive reasoning. Now from your readings yesterday, how do you define deductive reasoning in your own words? Because deductive reasoning is this. It's a type of logic in which one goes from general statement, good morning, general statement to a specific statement. So our clue here is simply deductive reasoning is from general to specific. So just take note of that. Again, when you say deductive reasoning, that's from general to specific. Okay? That's from general to specific. Let's have an example. All men are mortal. When you say mortal, what do you mean by that? Okay. Oh, capable of dying. Because when you say immortal, okay, people like mga gods and goddesses, they are immortals, right? So, all men are mortal because we are capable of dying. That's a major premise because that's true to all men. Okay? If you're a person, then you are mortal. You are capable of dying. That's a major premise. A major premise is simply a general statement. When I say general statement, those are facts or statements which are true to all. Let's go to the second statement. Socrates is a man. That's a minor premise. It's a specific statement now, because we are simply naming a specific person. Socrates is a specific person. He is a man. Therefore, Socrates is mortal, which will be a valid conclusion based on our major and minor premise. So take note, the major premise here is a general statement. The minor premise, that a specific statement. And we have made our conclusion based on the two. Is that clear, Section Ruby? Okay. We have a shortcut for this. Look at the shortcut. The shortcut is so simple. If you go over here, this state, kini siyang men, o kini siyang men, is common. So I'm gonna cancel it out. And what is left is Socrates, and here is mortal. Just make it like grammatically correct. Isumpay lang na, Socrates is mortal. So that's the one thing, the technique that I always do. I'm gonna be canceling the common phrases like all men and is a man. I'm gonna cancel that out. And what is left is I'm gonna be joining them. So Socrates, lain mo sa Socrates are mortal. Socrates is singular. So dapat Socrates is mortal. Is that clear, Section Ruby? Okay, let's continue. So this is an example of a syllogism or an example of deductive reasoning. Okay? Let's have more examples. All students eat pizza. Claire is a student at ASU. What's your conclusion here? Okay, so take note, this one, the subject here is all students. Here, the student here is found over the predicate. So I'm going to cancel that out. And let's combine Claire eat pizza. And let's have it grammatically correct. A stated statement. So Claire eats pizza. What about this example? All athletes work out in the gym. Barry Bonds is an athlete. What is your conclusion for this? Okay. So take note, athletes man ang common word. Athletes. Here. Cancel that out. We have Barry Bonds works out in the gym. That's totally right. Let's have another one. All math teachers are over 5 feet tall. Mr. D is a math teacher. What's your conclusion here? Okay. Math or Mr. D is over 7 feet tall. That's totally right. Now, with the statements 1, 2, and 3, let's go back to statement number 1. All students eat pizza. Who among you here does not eat pizza, man? Hey, there are students who does not eat pizza. We are making valid conclusions here. But I'm not saying that this statement is true. So take note, that does that mean that your conclusion is true, but it's valid. So we are making valid conclusions, but I'm not saying that this statement is true. Same thing with number 2. Not all athletes work out in the gym. They work out like outside. They just make their own mga materials or mga materials like they are very resourceful in terms of working out. So these conclusions are valid, but these conclusions does not tell that it is true. So the argument here, the 3 arguments are valid, but certainly is not true. So take note of that lang ha. Your answers are all valid, but I'm not saying that your answers are all true. The above examples are of form. Look at this one. The major. Yes, yes. Okay. It's okay. No problem with me if you're not gonna write therefore there. As long as Mr. D is over 7 feet tall, that's totally fine. By the way, mathematically, the symbol for therefore is this. So we have a symbol for therefore. This. Sorry. Okay. This one, the 3 dots making a triangle, that's the symbol for therefore. Okay? That's a symbol for therefore. So I can write this as, I'm going to cancel this out, and I'm going to be having the 3 dots here. Therefore, Mr. D is over 7 feet tall. And therefore, there is your conclusion. So those are examples of deductive reasoning. We started with a major premise, our general statement, followed by the specific statements. Look at our examples previously. Atong examine atong examples. Para we will really determine, that's a general statement. All students eat pizza. Eat pizza, I mean. That's a general statement. all athletes. It's a general statement. The clue here, if there's the word all, it's a general statement right away. And if you'll be mentioning specific people, like Claire, like Barry Bonds, those are specifics na. Is that clear, Section Ruby? Okay, let's have more on this. Let's have this one. Gonna be presenting to you an exercise that where are you? Here you go. This one. So let's have number one. Is this clear? Let's have number one. Who would like to give, these are deductive reasoning. Capital, taking a person's life is always wrong. That is a general statement. Capital punishment involves taking a person's life. So what is your conclusion for this? Okay, capital punishment is always wrong. Take note, have you noticed taking a person's life, and then here involves taking a person's life is common. So I'm gonna be combining capital punishment is always wrong. What about number two? Every human being has rights. John is a human being. Therefore, John has rights. That's totally right. What about number three? Every rectangle is a parallelogram. Every parallelogram is a quadrilateral. Therefore, correct. Okay, we will be canceling parallelogram, and I will be combining every rectangle is a quadrilateral. That's totally right. What about number four? Isosceles triangle have two equal sides. Triangle ABC has side measurements of 10 inches, 10 inches, and 20 inches. Oh, what's your conclusion here? What's your conclusion? Correct. Very good. That's totally right. Why? Two equal sides. 10 inches and 10 inches shows me two equal sides already. Therefore, triangle ABC is an isosceles triangle. That's correct. Is this clear, Section Ruby? So this time, it requires analysis. What about number five? Acute angles have measures less than 90 degrees. Angle XYZ measures 100 degrees. Okay, angle XYZ is not an acute angle. That's totally correct. What about number six? Supplementary angles are angles whose sum is 180 degrees. Angle CPU and angle WEB measures 120 degrees and 60 degrees consecutively. Okay, angle CPU and angle WEB are supplementary angles. That's totally right. Because when you add 120 and 60, the sum is 180 degrees. Number seven, complementary angles are angles whose sum is 90. Angle 1 is 54. The measure of angle 2 is 46 degrees. What can you say about angle 1 and angle 2? Are they complementary? You add the 54 and... Okay, so angle 1 and angle 2 are not complementary angles. Number 8, every high school student studies geometry. Maria is a high school student. Therefore, correct. Maria studies geometry. Those are examples of deductive reasoning. Okay, is this clear now? Okay, let's continue. Let's have inductive reasoning. Inductive reasoning involves going from a series of specific cases to a general statement. This time, we will turn things around. We will start with specific statements going to a general statement. So the conclusion is that in an inductive argument is never guaranteed. Okay? So example, what is the next number in the sequence? 6, 13, 20, 27. How did you get 34? Okay. So the pattern is, look at this one. This is plus 7. This is plus 7. This is plus 7. So meaning the next number is 34. This is an example of inductive reasoning because the pattern is simply adding 7 to get the next term. That's a general statement there. So when you find patterns, because patterns are general statements, because a pattern is true to all, look for a pattern that is true to all. Is that clear, Section Ruby? Okay, let's have more examples. Finding patterns. Find the next 3 numbers or terms in each pattern. 7, 12, 17, 22. So look for a pattern. Usually a procedure or rule that uses the same number or expression in each time to find the next term. Like example, adding 5 or adding 10 or adding a certain number to get the next term. Okay? Okay, let's verify that. So look at this one. It's simply adding how much? Adding 5, adding 5, adding 5. So to get the next term, 22 plus 5, 27. 27 plus 5 is 32. 32 plus 5 is 37. Therefore, the next 3 terms are 27, 32, and 37. Let's have our second example. What about this one? What's the pattern here? Minus 3. Okay. Minus 3, minus 3, minus 3. So to get the next term, 36 minus 3, 33. 33 minus 3, 30, correct? 30 minus 3, that's 27. Therefore, the next 3 terms are 33, 30, and 37. Next. Find the next 3 numbers. Here. What is the pattern? Times 3 this time. Look at the pattern here. Multiply by 3. Multiply by 3 to get 27. 27 times 3, that's 81. Therefore, the next 3 terms are, start as 81. 81, which is the last term sa example, sa given, it times na to nag 3 to get 243. Then, kanang 243, it times na po nag 3. Yang 729, it times og 3. So, you will have 243. Sorry, that's not correct, ha? That's 243. That's 729. This is not right. This is 243. That's 729. And 2,187. Next. 256. 256 divided by 2. That's 128. 128 divided by 2. That's 64. So 64 divided by 2. 64 divided by 2 is how much? 32. 32 divided by 2, 16. 16 divided by 2. Okay, there you go. Nagkabali-bali na sila. And those are your answers. 32, 16, and 8. Okay? Let's have figures with patterns. So, let's have how many sticks are there in figure number 1? There are 3 sticks. In figure number 2, how many sticks are there? 5. In figure number 3, how many sticks are there? 7. So how many sticks will there be in figure number 4? So what's your answer? What's your answer? There are 9 sticks. Okay? Because the pattern is simply plus 2. Or if you want to draw the next or the next figure, you can. But you can also count the number of sticks because it's easier. 3, 5, 7. Right away, you can give me the pattern. So it's plus 2. Okay? Let's have this one. How many, this time, how many squares? Squares din ta. How many squares are there? This is kini 1 square. For the second figure, 3 squares, 3 squares. 1 square, 3 squares. What about the third figure? 5 squares. What about the fourth figure? 7 squares. So what is the pattern here? Plus 2 again. So the fifth will give me 9. The sixth will give me 11 squares. Okay? Next. What about this one? How many sticks are there in figure number 1? How many sticks are there? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What about in figure number 2? Figure 1 eh. In figure 2, how many? There are 19. What about in figure number 3? There are how many? 26. What about figure number 4? Now, what's the pattern? Have you seen the pattern already? It's plus 7. So, meaning, figure number 5 will give me how many sticks? 38 sticks. Now, figure number 6, how many sticks will there be? 45. Because the pattern is plus 7. So, take note lang, yes. 26. Again. There are 33. Di ay ni. So, sayop ni ha. Thank you for that. 33. 33 plus 7. This is not 38. This is 40. And this is 47. So, is everything clear now? Okay. Let's continue. What about this one? How many dots are there? You have seen already. 1, 3, 6, 10, 15. If I'm going to have 4, how many dots will there be? How many dots will there be? Are you sure it's 18? $21. How did you get 21? How did you get 21? Look at that. Look at this one. This is plus 3. Plus 4. Plus 5. So meaning the next one is plus 6. plus 7. So, ang fifth nako is what is this? Plus 7. 28. Human plus 8, plus 9, plus 10. So, those are patterns also. It's not just like you're adding a common number. You simply add numbers na nagsunod-sunod is also a pattern. Yes. It's totally fine. Yes, it's fine. Anyway, this is recorded. Okay. We're not yet done. Okay. Keep. This time, let's go to our exercise book. There you go. Let's have this one. Number 1, what is the next number? What's the pattern, by the way? What's the pattern? Plus 4. So 20 and 24. What about number 2? No, it's not 31. What's the next two numbers here? It's not 32 or 41 either. Look at the pattern. 1, 4, 9, 16, 25. Diba this is the first term, the second term, the third term, the fourth term, and the fifth term. This is 1, 2, 3, 4, 5. What is 1 times 1? What is 2 times 2? What is 3 times 3? 4 times 4. 5 times 5. So what's the next term? 36 because 6 times 6 naman eh. The next term ani is 7 times 7 which is 49. So these are what you call the perfect squares. Remember the perfect squares? 1, 4, 9, 16, 25, 36, 49, 64, 81. Okay? So those are patterns as well. What about this one, number 3? What are the next two terms? Minus 2, correct. The pattern is minus 2. So 1 minus 2, 1 minus 2, negative 1. Negative 1 minus 2, negative 3. Okay. Let's have our fourth one. This one. Divided by 2, right? Is this divided by 2? So the next term is 25 divided by 2. No. 12.5. And 12.5 divided by 2 is how much? 6.25. Correct. Okay? What about number 5? Look at number 5. Look at number 5. What is another way of writing 1/2? How do you write 1/2? Another way of writing 1/2, aside from 0.5, aside from 2 over 4. If I'm going to have 3 here, 3 over how much money? 3 over 6. If I'm going to change this to 3 over 6, look at this one. What's the pattern now? 1, 2, 3, 4. So the next one is 5, 6 ang numerator. Denominator, look at the denominator. 8, 7, 6. So meaning this is 5 over 3. 5 over 3, right? Sunod, 6 over. Okay, 1, 2, 3, 4, 5, 6, 5 over 4. 5 over 4. and then 6 over 3. Correct. 5 over 4 and 6 over 3. Is that clear? Okay. So those are examples of inductive reasoning. By the way, what if I'm gonna give you this one? What if I'm gonna give you this one? I'm gonna have 1. Ang kanang fraction, that's simply adding 1 sa numerator and adding 1 sa denominator. Okay, what should be the next pattern? What's the next number? For this one. What is the next number? It's not 6. 8. Why 8? Why 8? Come on, why 8? Correct. Very good. That's a very good observation. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5, 8 will be the next number there. This, 1 plus 1 is how much? 2. That's the next one. What is 1 plus 2? 3. What is 2 plus 3? 5. Oh, what is 3 plus 8? 3 plus 5? 8. And this is what you call a Fibonacci sequence. Because a Fibonacci sequence is simply adding the two terms to get the next term. So that's still a pattern. Okay? Adding the two terms to get the next term is still a pattern. Is that clear? Okay. Now, let's go to the figures. Let's go to the figures. Here. I'm going to minimize this first. Okay. How many unshaded squares will there be in figure number 10? Okay, you think of an answer for this. Figure number 1 has how many unshaded? How many? For the figure 1, how many unshaded? Unshaded. 1, 2, 3, 4, 5, 6, 7, 8 ni. 8 ni ang unshaded. 8 ni. Right? What about in figure number 2? How many? This is 8. In figure number, let's count ha. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. What about figure number 3? 12. Figure number 4. Figure number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unshaded man. Kanang wala gishadan. Okay? 12, 14. So what will be the answer to the question here? Figure number 10. Again, how? 26. Is it 26? Okay, it's 26. So the next here is 4. 4 will have 16. 16. Then 18. Then we have 20. 22. 24. 26 ang figure number 10. Is that clear, Section Ruby? Okay. So same thing with that. Those are just examples of inductive reasoning. So are there any questions about our lesson for this morning? Yes, yes. What's your question? 12. What about the 12? Kini siya? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Na may stick sa sulod. Yes. Okay. Some more questions. So, yes. Go. State. Yes, pwede siyang ma-statement ang inductive reasoning. I'm gonna give you an example. Example na to. Baby J cries when hungry. Baby Karen cries when hungry. Baby Ellen and baby Maria cry when they are hungry. Therefore, babies cry when they are hungry. That is an example of inductive reasoning because I started with specific statements. Like I mentioned, babies nga nag-cry because they are hungry. And then I gave a general statement nga, all babies cry when hungry. Or another one, in science. Vinegar turns blue litmus paper to red. Milk turns blue litmus paper to red. Calamansi turns blue litmus paper to red. Vinegar, milk, and calamansi are acids. So what's my general statement here? Therefore, acids turn blue litmus paper into red. That is an inductive reasoning. Why? Because I started with specifics. Vinegar, milk, and calamansi, those are specific examples. And I come up with a general statement that all acids turn blue litmus paper into red. It is possible. Nga, these are just, dili lang kay numbers ra ni sila. Okay? But when we have, like in mathematics man good, we always, in solving like mga topics na to sa algebra, we always use inductive reasoning on that. Sa inyong science, you do inductive reasoning as well. You do experiment, you collect data, and after which, you make a conclusion, a general statement that will conclude the experiment you have. Is that clear? Okay. So that does not mean nga, big numbers are right away, puro siya inductive. Nasa ba mga inductive, deductive ka numbers? So just analyze. Analyze jud na nato ang example nato. General to specific is deductive. Specific to general is inductive. When I say general statement, it's a statement for all. It's a general truth. It's a fact. When I say specific, mentioning, like mag-mention of specific person, specific things. So those are specifics. Mo ni ako ilhanan, ako sang analyze maayo. Oh, let's have an activity on that. Look at this one. I have an activity on that here. Where are you? This is kinds of reasoning, this one. Look at this one. Let's start with number 3 number 4. Let's go to number 4. Man is a rational being. Joshua is a man. What's your conclusion here, Section Ruby? And what kind of reasoning is this? Deductive. Kay man is a rational being is a general truth. It's true to all. Okay? Therefore, this is deductive reasoning. What about statement, example number 5? Parallel lines do not intersect. Lines L and M intersect at P. What's your conclusion? Lines L and M are not parallel lines. And this is an example of deductive gihapon because parallel lines do not intersect is a general truth. It's a general truth. Mention din og specific. What about number 6? 5 plus 9 is 14. 11 plus 13 is 24. 9 plus 11 is 20. 35 plus 5 is 40. What's your conclusion on this? What kind of number is 5 and 9? Is this odd or even? What about 11 and 13? Odd. What about... Okay, when you add 2 odd numbers, it's always even. That's a general truth. That's truth all the time. When you add 2 odd numbers, it's always even. And that is an example of inductive reasoning. Because we started with specific, and we came up with adding 2 odd numbers is even, which is inductive. Number 7, this is deductive. Math teachers are good Scrabble players, a general statement. Nag-mention the specific names nila. Okay? Same thing with number 8. This is still deductive. Nag-mention the measure of any acute angle. It's a general truth. Acute angles measure less than 90. Okay? This one, for sure, kining 9 and 10, nag-start manggod siya og 2 plus 6. Kini kay, these are all inductive. Pero be careful ha, not all of these numbers, you need to analyze. Okay? Are there any questions about our lesson for this morning, Section Ruby? Ang number 10, you need to write the pattern first. The pattern is simply subtract 2 to get the next number, and the next term is simply 0. That's your conclusion there. But I'm going to accept 0 for that. Because if you're going to be getting 0, for sure, you were able to get the pattern there.